Imagine you are Priya, right? A
Right.
cloud engineer, and you're prepping for a major presentation.
Oh, yeah, high stress. We've all been there.
Exactly. You need a quick answer, so you ask your company's internal AI chat assistant for the parental leave policy,
Okay.
and it instantly spits back this beautifully formatted, highly professional answer. I mean, 16 weeks of paid leave, manager approval required within 5 days, and unused leave cannot be carried forward.
Sounds very legitimate.
It sounds perfect. It has the exact corporate tone of your HR department. But here's the problem. Priya never actually uploaded the policy document.
Oh, no.
Yeah, the AI just confidently hallucinated a completely plausible corporate lie.
Well, see, the thing is, it did exactly what it was mathematically designed to do.
Right.
It just blended patterns from countless corporate policies it saw during its training, you know? And it generated details that might belong to some organization out there in the world, just not hers.
Welcome to No Hype AI, the deep dive that explains modern AI without all that unnecessary complexity or, vendor hype.
Glad to be here.
This deep dive explores a core concept from the book The AI Builders Foundation, which is this really practical, no-hype guide to understanding AI and learning to build with it. You'll find the link for that in the description, by the way.
It's a great resource.
It really is. And our mission for you today is to go under the hood. We're going to deconstruct the exact mathematical engine that makes a model sound so incredibly fluent, yet, as we just saw, lie so confidently.
Yeah, we'll explore how predicting text token by token creates these massive capabilities and why the AI's context is, well, very different from human memory.
Right, and most importantly, how you, as a developer or just a user, can build reliable systems around it.
Because Priya's story actually has a second act.
Oh, right.
Yeah, when she finally supplied the AI with the actual PDF of her company policy and restricted its instructions, basically telling it to only summarize what was in that specific document, it gave her a flawless factual summary.
Right. But here's the part that just blows my mind. The model didn't suddenly grow a conscience or realize it had been lying earlier.
Not at all.
It used the exact same core mechanism to generate the flawless truth as it did to generate the complete fabrication.
Exactly. Both of Priya's answers came from the exact same underlying capability. We are talking about an autoregressive generative language model.
Which is quite the mouthful.
I know, that sounds like a massive piece of jargon. But its fundamental job is astonishingly simple, really.
Okay.
It looks at a sequence of text, and it calculates the mathematical probabilities for the very next unit of text.
Just the next piece.
That's it. It picks the next piece, adds it to the sequence, and repeats that operation over and over again to generate a response.
Okay, let's unpack this for a second because this is where my brain always starts to push back.
Go for it.
If this multi-billion-dollar AI is fundamentally just playing a high-speed guessing game, I mean, if it is literally just a steroid-injected version of my iPhone's autocomplete, how on earth can it write a functioning Python script to debug my back-end architecture?
Right.
Or how can it explain the intricacies of quantum mechanics or write a coherent legal contract?
That skepticism is totally warranted. And it's exactly why calling it just autocomplete massively understates the reality of scale.
Okay, scale.
Yeah, this isn't your phone guessing the word there after you type hello. By trying to predict the next piece of text across billions of pages of broad text data. I mean, we're talking from Reddit threads to GitHub repositories to all of Wikipedia. The model is forced to learn the underlying structures of reality just to get the prediction right.
So it's not just learning words, it's learning the scaffolding behind the words.
Precisely. To predict language well across that enormous range, an autoregressive model must capture grammar, coding syntax, logic, relationships between concepts, forms of argument.
Wow, okay.
If the sequence of text is a half-finished math problem, the most statistically probable next unit of text is the correct mathematical step. There is no handwritten coding module or like a summarization folder inside the AI.
It's all just emergent.
Yes, exactly. These broad capabilities naturally emerge from the monumental, complex task of modeling human language at scale. The internal representations it builds to solve that prediction game are what allow it to support such a huge variety of tasks.
That actually makes a lot of sense. But to really understand how the AI predicts that next piece, we have to get highly specific about what it actually considers a piece.
Yes, we do.
Because it definitely doesn't read words the way you and I do. Like, if I look at the word apple, I see a complete word made of 5 letters.
Right, but the model doesn't see that at all. Language models process what we call tokens.
Tokens.
Yeah, tokenization is the first and really the most critical conversion from human-readable text into the mathematical units the model can actually process. A token might be a whole short word, part of a longer word, a single punctuation mark, or even just a blank space.
I always like to think of tokenization like Lego bricks.
Oh, that's a good way to look at it.
Like a really common word, say apple, is probably a pre-molded single Lego piece. The model just grabs it all at once. But an unusual name, or some highly technical cloud-native term, the model might have to chop that up into 5 weirdly shaped little bricks just to digest it.
That's a perfect analogy. And what's fascinating here is that this tokenization process is strictly a mathematical conversion based on statistical frequency.
Okay.
It is not understanding in the human sense. It's just an algorithm, often something like byte pair encoding, making human text digestible for a machine. And if you are an engineer building with these tools, this explains so many practical, frustrating quirks you might experience.
Like why early AI models were notoriously terrible at counting characters in a word, or why they struggled so much with rhyming.
Exactly. Because the model operates on tokens, not individual letters. It doesn't see the letters A, P, P, L, E. It just sees a single ID number representing that chunk.
Oh, wow.
It also has massive implications for coding. Because tokenization relies on frequency, trailing white spaces in Python code might tokenize completely differently than code without them.
So a space makes a difference.
Huge difference. A space combined with a specific bracket might be one single token, but if you add a tab, it shatters into 3 different tokens.
Which means the model is suddenly looking at a totally different mathematical sequence. That is wild.
Yeah, it changes everything.
I also know this is why non-English languages can eat up your API usage limits so much faster.
Yes, the token penalty.
Right. A common English phrase might be 3 tokens, but representing that exact same meaning in a language with less representation in the training data might take 10 or 15 tokens. You're literally paying a premium because the model has to use more bricks to build the same house.
Spot on. But, this brings up a massive architectural question.
What's that?
If the model is just processing these digital Lego bricks one by one, constantly guessing the next one, how does it not forget the beginning of the sentence by the time it reaches the end?
Oh, right. How does it keep track of a 50-page document without losing the plot entirely? Because if you upload a massive engineering log, how does it know what error happened on page 1 when it's summarizing page 50?
This is solved by 2 foundational concepts, the context window and the attention mechanism.
Okay, let's break those down.
So the context window is the maximum amount of material the model can consider at once. Think of it as the model's absolute field of vision for a single operation.
Field of vision, okay.
This window includes your prompt, any system instructions developers have set, the conversation history, retrieved documents, formatting requirements, basically. Everything must fit in that window.
Okay, so you cram everything into the window, but how does it actually make sense of it all simultaneously?
That's where it uses the attention mechanism. Attention is a mathematical architecture that allows the model to weigh the relationships among all the tokens in that current context window simultaneously.
Weigh the relationships.
Yeah, it creates a dynamic matrix. Imagine every token gets assigned a vast list of numbers, a vector representing its meaning. The attention mechanism compares these vectors to see how much focus one token should give to another.
So if the token is the word bank and it's sitting near the token for river, the attention matrix highlights the water relationship.
Exactly.
But if bank is near the token for money, it highlights the financial relationship.
Exactly. And over long distances, too. If a paragraph introduces a character named Maya on page 1 and later uses the pronoun she on page 10, the attention mechanism helps mathematically connect the token she back to the token Maya, maintaining that narrative thread.
Okay, but this leads right into a huge misconception that I see everywhere.
Let's hear it.
If the AI has this massive context window and this incredible attention mechanism tracking all these relationships, does that mean it has a perfect memory of everything we've ever talked about? Because when I log into my chat app, it remembers my name, my coding preferences, and what we debugged last Tuesday.
If we connect this to the bigger picture, this is one of the most dangerous misconceptions for any user, but especially for developers handling secure data. Context is not memory.
Wait.
Context is simply the material available during the current inference, meaning the current prediction it is running right now. The underlying language model itself has 0 persistent personal memory of you. once that specific calculation is finished.
Wait, hold on. You're telling me my AI assistant doesn't actually remember me?
Nope.
It's basically doing the movie Memento every single time I hit send. Like, it wakes up with amnesia, reads a script of our past to figure out who I am, and then acts like it knew me the whole time.
It absolutely is doing Memento. That completely shatters the illusion, doesn't it?
Completely.
The helpful assistant you are interacting with is an illusion assembled from multiple software layers. What's actually happening is that the surrounding software wrapper, the application built around the model, saved your past conversations in a traditional database.
Oh, I see.
When you ask a new question, that software silently pastes those old facts into your current context window behind the scenes before hitting send to the model.
That distinction matters so deeply for digital privacy and data retention.
Crucially so. A cloud service might store your entire conversation history on their servers in plain text, even though the raw AI model has no persistent memory.
Right.
Conversely, if you click Delete Chat History in the user interface, you might just be clearing the visible UI. That doesn't by itself explain every data retention practice happening on their backend databases. The application's policies dictate your privacy, not the neural network.
Here's where it gets really interesting. I hear developers and users constantly blaming the AI when it refuses to answer a question or when it tries to browse the web and fails.
All the time.
Right. Without realizing they are actually critiquing the outer software wrapper, not the model itself. It means we have to understand the journey from a raw base model to a chat assistant.
Let's break down that pipeline, because you're right, they are two very different beasts. It starts with a phase called pre-training. We expose a massive neural network to large collections of text data and train it to simply predict continuations.
And that gets us.
The result of that massive compute effort is what we call a base model. But a base model is purely a pattern continuer.
So if I give a raw base model a prompt like write a Python script to delete a directory, it doesn't know if I'm a system admin doing routine maintenance or a malicious actor trying to wipe a server.
Exactly. It doesn't know and it doesn't care. It might output the script perfectly because that's the statistical continuation.
Yeah.
Or it might just generate 3 more related coding prompts because, well, sometimes text on forums is just lists of questions.
Right.
It is not automatically learned to behave as a safe cooperative assistant.
So how do we get the polite, helpful AI we actually use?
To make it helpful, developers put it through a second phase, instruction and preference training. They use curated examples, human feedback, and sometimes AI feedback to reward helpful behavior and heavily penalize harmful or useless responses.
And that's what makes the assistant.
That transforms the base model into an assistant model.
But even the assistant model isn't the final product we use on a website, is it?
Right. The final chat product has a whole third layer. The engineers wrap the assistant model in a complex system architecture. They add hidden system instructions like always be polite or never write malware.
Okay.
They add API connections for web search capabilities, safety filter guards, file retrieval databases, and code execution environments. You simply cannot infer how the base model works mathematically just by looking at the consumer chat application.
Which brings us to the biggest trap of all.
Yeah.
Now that we know this system is highly trained, layered with all these instructions to give you cooperative, polite, human-like answers, we confuse that incredible fluency with factual truth.
This takes us right back to Priya's hallucinated company policy from the beginning.
Yeah.
You have to remember what a language model is rewarded for during its core training. It is rewarded for producing highly probable linguistic continuations.
Just sounding right.
Exactly.
Yeah.
It's not rewarded for pausing, consulting a verified database of reality, and then generating a sentence.
So it literally doesn't know the difference between a fact and a well-structured fiction.
Right.
A hallucination isn't the AI glitching out, it's just generated content presented as though it were supported by facts when it isn't. It's often coherent precisely because the model has learned exactly what a convincing, authoritative answer looks like.
Exactly. Truthful text is very common in its training data, so the model often gives accurate information. But a plausible falsehood fits the mathematical pattern of language just as well.
Wow.
And there are specific triggers that make these hallucinations highly probable. For instance, if your prompt assumes a false premise, the model might just politely play along because cooperative dialogue is what it was fine-tuned for.
Or if the fact you request is obscure, very recent, or absent from the current context window, it will likely just guess based on statistical vibes.
Yes. Or if the prompt pressures the model to provide a definitive answer rather than allowing it to admit uncertainty, it will prioritize sounding confident over being correct.
Which raises a highly practical question I hear all the time from people trying to use these tools for work.
What's that?
Can I just ask the AI, are you sure about that? To double check its work.
This raises an important point about verification, and I cannot stress this enough. Asking the model, "Are you sure?" is a terrible verification strategy.
Really? Why?
If you do that, the model does not go back and logically review its previous math. It simply looks at the context window, sees that you asked if it's sure, and generates a much more confident-sounding version of the exact same mistake.
Oh, no.
It's just generating more tokens that fit the linguistic pattern of an expert doubling down.
So how do we actually get reliable truth out of this thing, especially if we are building enterprise applications?
You have to fundamentally separate learned model knowledge from retrieved knowledge.
Okay, what's the difference?
Learned model knowledge is all those statistical relationships absorbed during the initial pre-training. The model might reproduce a fact from learned patterns, but its neural weights do not provide a clean citation showing where a claim came from. It blurs facts together.
Right. Learned knowledge is just the AI vibing based on its training.
Exactly. Retrieved knowledge, on the other hand, is supplied at inference time from an external source. This is a framework often called retrieval augmented generation, or RAG.
Ag. Yeah, we hear that a lot.
You intercept the user's question, query a vector database for factual documents like Priya's actual company policy, and then paste those documents into the context window alongside the prompt. You explicitly instruct the model. Answer this question using only the provided text.
So you turn the interaction from a closed book memory test into an open book reading comprehension test.
Precisely. You use retrieval when answers depend on private, current, or exact sources. Now, retrieval still doesn't guarantee absolute truth. I mean, the search algorithm could grab the wrong passage, or the source document itself could be inaccurate.
Right, garbage in, garbage out.
But it tethers the AI's language generation to reality and makes the answer completely auditable.
Okay, so we've established how to ground the AI's words in reality using external documents. But what happens when we want it to go beyond words? This is huge for developers right now. What if we want the AI to actually do something in the real world?
This is a critical boundary line. Generating tokens is not the same as taking an external action. A language model, by its mathematical definition, cannot send an email.
Right.
It cannot transfer money, access a private AWS bucket, or update in SQL database.
Wait, hold up. But I've used AI tools that book meetings and send emails for me.
The AI isn't sending the email. The model only generates the text requesting that action.
Oh, I see.
Through a process often called function calling or structured output. Developers prompt the model to output its response in a highly specific machine-readable format, like a JSON file.
Okay.
It produces structured text that says something like action, send email, recipient.x, subject y. The surrounding software, the Python or Go code wrapped around the model, parses that JSON and triggers the actual API to execute the action.
So what does this all mean for you? It means the risk profile changes entirely once words become actions.
Absolutely.
Think about it. A hallucinated, flawed draft of a report is just annoying. You read it, you delete it. An automated hallucinated JSON string that instructs your system to send a bad email to a client or drop a production database is a total disaster.
Exactly. The AI is the brain coming up with a plan, but you never give it direct control of the steering wheel without fail-safes. This is why tool use should always include narrow API permissions, extensive logging, starting conditions, and human-in-the-loop approval for destructive actions.
This also perfectly highlights when a language model is explicitly the wrong tool for the job.
Yes. You should never use a language model to calculate complex arithmetic. It's guessing the next token. Just use a traditional calculator script for that.
Makes sense.
Don't use it to query a database for an exact account balance without using structured retrieval. And absolutely never use it to enforce access control or decide if someone has permission to view a secure record.
Let the AI act as the friendly interface. The dynamic translator between human intent and machine code, but never let it be the source of truth or the engine of exact mechanics.
Well said.
Also, since we're talking about architecture, bigger isn't always better here. We hear so much hype about massive large language models with 1 trillion parameters, but small language models are incredibly vital.
And often vastly preferable for developers. If your job is narrow, like classifying inbound support tickets as urgent or not urgent, or formatting raw text into a consistent JSON schema, a small model is faster, vastly cheaper, and can run locally on an edge device to protect user privacy.
Yeah.
A massive model is better for ambiguous, complex reasoning requests that require broad world knowledge. You choose based on measured performance in the workflow, not just on size.
Okay, let's rapidly distill the core takeaways from today's deep dive.
Let's do it.
1. Text is generated token by token. It's a mathematical prediction based on scale, not human thought or understanding.
Right.
2. Context is not persistent memory. Your app is just pasting in your history like the movie Memento.
Yep. Amnesia every time.
3. The chat product is a complex system layered over a base model. Don't judge the engine purely by the steering wheel.
Good analogy.
4. Fluency is not proof of truth. Confidence is just a linguistic pattern, so force the model to use retrieved knowledge. And 5. Generating text is distinct from taking action. The AI writes the JSON request, but your software pulls the trigger.
If you keep those principles in mind, you stop treating AI like a magical, infallible oracle, and you start using it like what it is, a powerful, highly capable, but predictable language transformation engine.
Which leaves us with a final, lingering question to ponder on your own.
I love these.
If AI models are mathematically optimized to perfectly mimic the fluency, tone, and confidence of a seasoned expert, how will you evaluate the credibility of what you read tomorrow? Will we soon live in a world where clunky, awkward, grammatically flawed writing becomes highly valued, simply because it's the only proof a machine didn't write it?
Wow. Something to think about.
If this deep dive helped you understand AI more clearly, follow No Hype AI on your podcast platform or subscribe to @RahulSidPatil on YouTube for more practical content about Go, cloud-native engineering, and AI-native development. This conversation was produced using Notebook LM's AI-generated hosts and is based on the book The AI Builder's Foundation. You'll find the book and author details in the description.